Every single day, roughly 1,000 people die at work worldwide.
Yeah, it's a completely staggering number when you really think about it.
It is. And, if you zoom out to look at the broader financial impact, like the direct and insured costs of industrial incidents, we're talking chemical spills, deep water rig explosions, structural collapses.
Right.
Those costs hit the trillions of dollars annually. But, the most tragic part of this hidden global crisis isn't just the sheer scale of the destruction.
No, it's that we actually already have the data to stop it.
Exactly. We just aren't legally allowed to share it.
And that is exactly the frustrating ground-level reality we are exploring today.
Right.
Because when you study the autopsy of, almost any catastrophic industrial event, there is always a precursor.
Always some kind of warning sign.
Exactly, a tiny warning sign that someone somewhere in the industry has seen before. But because of how corporate data is legally siloed, that life-saving knowledge gets trapped. It gets stuck inside individual companies.
Which brings us to our focus today. For this deep dive, we are looking at an internal pre-publication draft of a press release from a company called EON AI Ventures.
Yeah, a fascinating document.
It really is. They're launching a highly specialized AI model called EON Delta. And our mission today for you listening is to explore how AI is being deployed to solve this massive structural roadblock in industrial safety.
Right, and we're stripping away all that glossy Silicon Valley hype, too.
Yeah, totally. We are looking at hard, physical, boots-on-the-ground engineering constraints. So let's start with the root of the problem. If a critical component in a, manufacturing plant is about to fail, there's almost always a digital footprint, right?
Yes, always.
Like a pressure reading drifting a fraction of a percent off baseline. Or maybe a strange vibration pattern.
Exactly. The raw data required to catch these disasters before they happen is sitting on server racks across the globe right now.
But the knowledge doesn't compound.
It doesn't compound across the industry at all. As the EON draft points out, the core roadblock here isn't technical. It's entirely structural.
Right.
So imagine two rival companies, fierce competitors, but they're both operating the exact same piece of heavy equipment.
Let's say it's a massive, complex industrial turbine.
Sure, a turbine. So Company A's turbine explodes. They spend weeks investigating, and they realize the failure was triggered by a highly specific anomalous combination of temperature and internal pressure over, say, a 6-week period.
Okay. And meanwhile, Company B's turbine across the country is experiencing that exact same anomalous combination right now.
Right now. But Company A cannot pick up the phone and warn them.
Wow. Even if lives are on the line.
Even then, because doing so exposes competitively sensitive operating data.
Right. Trade secrets.
Exactly. To show exactly how your machine failed, you have to reveal exactly how you were running it. Your production volumes, your stress thresholds, those are closely guarded secrets.
That makes sense from a business standpoint.
It does. Furthermore, in many jurisdictions, setting up a data-sharing pipeline between two major market competitors is, well, it's a fast track to an antitrust lawsuit.
Because it looks like collusion.
Exactly. Regulators view that kind of data exchange as constructing an unlawful channel of communication. It could easily be leveraged for price fixing.
So it's like discovering a massive, deadly pothole on a dark highway, blowing out your tire, but you are legally gagged from putting up a flare to warn the drivers behind you.
That is a perfect analogy.
You just have to sit on the shoulder and watch every single car hit the exact same pothole, blow the exact same tire, and pay the full cost in lives and money over and over again.
It's a tragedy of unshared lessons. The industry is independently discovering the exact same failures repeatedly.
Right.
So the engineering challenge for EON was, well, how do you extract and share the knowledge hidden inside the data when sharing the raw data itself will land your general counsel in federal court?
So if sharing raw data is a legal minefield, you basically have to find a way to separate the lesson from the data.
Exactly. And EON Delta attempts to do this with what they call a two-layer architecture.
Right. This is where it gets really clever.
It is. They physically and mathematically decouple the proprietary facts of a specific factory from the generalized physics of industrial equipment.
So how does that actually work in practice?
Well, the architecture is split into the Tenant Delta and the Base Delta.
Okay, let's break those down.
The Tenant Delta is the private layer. It is trained strictly on the individual customer's own material, entirely inside their own secure, firewalled environment.
So it never leaves their building.
Never.
And EON categorizes this private layer as derived insight, right? Like the customer completely owns it.
Yes. If they decide to leave the consortium tomorrow, that Tenant Delta layer is either returned to them in full or verifiably destroyed on exit.
Okay, so that's the private side. What about the shared side?
Sitting underneath that private layer is the base delta. This is the shared layer. But, and this is crucial, it only contains patterns that have been independently qualified against multiple different organizations.
Or failure patterns already published by regulators, I think the draft said.
Exactly. So EON owns this base layer as a generalized learning, and they license it back to every single participant, royalty-free in perpetuity.
There's a line in the internal draft that frames this concept in a really compelling way. It says, a data set is a pipe. A model is a teacher.
Yeah, I love that quote. That metaphor gets right to the core of the breakthrough here.
So?
Well, if you share a data set, a pipe, you are moving raw, sensitive, proprietary information from one competitor to another. That instantly triggers the antitrust and privacy alarms.
Right, because you're literally handing over the secrets.
But a model, specifically a trained neural network, acts as a teacher. A teacher can read a highly proprietary textbook, internalize the underlying principles of chemistry or physics from it, and then teach those generalized principles to a rival student without ever handing over the textbook itself.
Wow. So the competitors aren't colluding. They're just learning from the same tutor.
Exactly.
But let me challenge the mechanics of that shared learning for a second. Let's say you're running a mid-sized chemical manufacturer and you plug into this system. Then a dominant global conglomerate joins and they bring like 10,000 times more data than your facility has.
Right, the data volume issue.
Yeah. Doesn't the shared base delta just become a proprietary clone of that one giant company simply by the sheer weight of their data flooding the training pool?
That is a critical vulnerability in shared models, yes. And ERN engineered a strict mathematical safeguard to prevent it.
Yeah.
They don't just dump all the incoming data into a blender and hope for the best. Before any training occurs, the system actively measures the proportion of training examples originating from any single organization.
So they categorize it by specific failure types.
Exactly.
So they basically put a hard ceiling on contribution volume to prevent a monopoly on the logic.
Yes. A specific failure pattern might appear in multiple sources, which satisfies the basic rule for entering the shared layer. But if 99% of the examples teaching that pattern come from company X,
the AI just turns into company X.
right, it inevitably starts mimicking company X's specific proprietary operating procedures. So by strictly capping how much data any one contributor can represent in a specific lesson, the base layer is mathematically forced to remain a generalized understanding of physics and mechanics.
Rather than a disguised blueprint of a monopoly's factory floor.
Exactly.
Okay, so we have a clever two-layer architecture and strict data caps. But, I mean, even with all that structural engineering, the AI is still learning from historical incident reports.
It is.
And those reports are written by human beings who already know how the story ends. If you train an AI on documents dripping with hindsight, aren't you just building a machine that's really good at predicting the past?
Yeah, this phenomenon is known as hindsight bias, and it is fatal to predictive modeling in the real world.
Fatal how?
Well, think about the human reality of an industrial disaster. It's a Tuesday afternoon. An engineer is walking the factory floor, thinking about their lunch break, and notices a pressure valve vibrating.
Right. Just a normal day.
In that moment, that engineer, it's just a vibrating valve. It's noisy. It's a typical factory. They might make a note on a clipboard and keep walking.
But a week later, after that exact valve ruptures and causes a catastrophic explosion, the incident report reads totally differently.
Exactly. The investigator writing the report says something like, at 2:17 p.m., the primary pressure valve began vibrating ominously, signaling an imminent cascade failure.
Right. The investigator can't help it.
They can't. They know the outcome, so every sentence they write subconsciously points toward the explosion. Now, if you naively feed thousands of these hindsight bias reports into a standard AI, the model learns the wrong lesson entirely.
What does it learn?
It learns to associate mundane baseline readings with absolute disaster. It becomes incredibly confident in situations that, at the time, were genuinely ambiguous.
So the AI is basically cheating at a test by peeking at the answer key.
That's a great way to put it.
Its laboratory metrics will look amazing because it's successfully predicting explosions based on obvious clues.
Right, but the second you put it on a real factory floor where the future hasn't happened yet and things are actually ambiguous...
It's going to panic over every normal vibration.
Exactly. It'll be useless.
So how do you blindfold the AI to the ending of the story during training?
EON Delta enforces a strict chronological cutoff. When constructing the training examples, they draw a hard line exactly at the moment of the incident.
Okay.
Only the information that was completely knowable before the event is fed into the prompt for the AI to study. The actual disaster outcome is severed from the prompt and becomes the answer the AI has to try and deduce.
Oh, wow. So it has to look at the just vibrating valve and deduce the risk without knowing it actually blew up?
Yes.
And the draft notes that if a historical report is so poorly documented that they can't do this before and after reconstruction,
Yeah.
they don't try to guess or estimate the missing data. They just throw the entire record out.
They prefer less data over biased data. It completely bucks the typical feed the model everything mentality we see in, consumer AI. And that rigidity applies to their legal compliance as well. EON operates what they call a closed failure mode for licensing.
What does that mean?
It means every single piece of text must carry a recorded determination of its legal usage rights. If that license record is missing, processing is entirely blocked. The machine literally starts.
Which raises a massive verification problem, doesn't it?
How so?
Well, if the entire premise of this system is that nobody, not even EON, is allowed to look at the private data in the Tenant Delta, how does an antitrust lawyer or a government regulator actually verify that these strict data caps and licensing rules are being followed? You can't audit what you aren't allowed to see.
You solve the auditing problem with cryptography, specifically cryptographic hashing.
Oh, okay, break that down for us.
So every single time a training run happens, the system takes all the metadata, the training examples, the sources, the license determinations, the data proportions, and the specific configuration.
Everything involved in the run.
Right, and it runs it all through a hashing algorithm.
And how does that hash function in this context?
A cryptographic hash basically takes any amount of data and condenses it into a fixed-length string of characters. It acts as a unique mathematical seal for that specific batch of information.
Like a fingerprint.
Exactly. And that hash is bound permanently to the resulting AI model. If a single comma changes in the training configurations, or say if one unlicensed document slips into the batch, the underlying math changes entirely.
And the hash breaks.
The hash breaks.
So a third-party auditor can come in, review the open-source hashing algorithm, and mathematically prove that every governance rule was followed to the letter without ever being granted access to the proprietary training data itself.
Precisely. They can audit the governance without compromising the trade secrets.
That is wild. Auditing a secure process without exposing the secrets is a huge structural breakthrough. But let's step away from the abstract cryptography for a minute.
Sure.
Because none of these elegant digital constraints matter if the AI cannot physically function in the environment where the metal is actually bending. We're talking about explosive chemical plants and subterranean manufacturing floors, not, climate-controlled tech offices in California.
Right. The physical reality of these industrial sites dictates the technology. For one, internet connectivity is often poor or entirely intermittent.
Or non-existent.
Yeah. Furthermore, in many highly secure or hazardous environments, wireless signals are strictly prohibited by law.
Oh, really? Why is that?
A stray radio frequency signal could interfere with sensitive telemetry equipment, or worse, spark an ignition. You simply cannot rely on a massive cloud-based AI if the Wi-Fi is legally mandated to be turned off.
So EON Delta doesn't live in a massive data center somewhere.
No.
It runs entirely locally, on physical on-premise hardware that an engineer literally carries through the factory door.
Yes, which, as a byproduct, elegantly solves the data residency issue, too.
Because it's physically trapped. You don't need a complex legal contract promising the data won't cross international borders if the physical box processing the data literally lacks a network card.
Exactly. The laws of physics enforce the data privacy.
I love that. But wait, fitting a highly capable large language model onto a local server box is notoriously difficult.
Yeah.
Standard models require, warehouses full of specialized processors.
They do, but EON gets around this using a mechanism called parameter efficient fine-tuning, or PEF.
I've seen PEFT mentioned in technical papers, but how does it actually shrink the computing requirements enough to fit a viable AI onto a local box?
So think of a standard, massive, open-weight base model as a university graduate. They have a broad, generalized understanding of language, logic, and basic physics.
Okay, I'm with you.
EON takes this graduate and freezes their knowledge. They don't change the billions of underlying parameters that make up the base model. Instead, they train a tiny adapter that sits on top of it.
So rather than sending the graduate back to school for 4 years to learn factory safety, You just hand them a highly specialized, pocket-sized cheat sheet.
That is a great way to visualize it. The adapter is a fraction of 1% of the size of the base model.
Wow, that's small.
Yeah. And because industrial safety judgment, while complex, is a very narrow, highly specific domain, this tiny specialized adapter, when combined with the frozen base model, can actually outperform a massive generalized AI on this specific task.
That's incredible.
And because you are only updating that tiny fraction of a percent during training, the compute power required drops exponentially.
So creating a custom bespoke AI for every single customer suddenly becomes economically viable and mathematically possible to run on a local unconnected server.
Exactly.
But there is one final constraint detailed in the draft that addresses, well, the elephant in the room.
The actuation issue.
Yeah. Whenever we discuss AI in industrial settings, people immediately picture a scenario where the AI decides to optimize production by locking the facility doors and turning up the pressure valves. Skynet, basically.
Right, but EON Delta is strictly forbidden from actuating equipment. It cannot press a button, it cannot flip a switch. It only advises the human engineers.
But, I mean, you can't just put a polite text filter on an AI and trust it. We've seen generative models hallucinate their way around safety filters constantly. If the model knows how to write a command script to open a valve, eventually, under the right convoluted prompt, it might output that script.
Which is exactly why they don't rely on output filters. They strip the capability out of the training data entirely.
Oh, really?
Yeah. Material used to teach the AI is actively scrubbed so that any recommendations to actually operate equipment or physically alter a control system are completely absent from the text.
So the AI doesn't know how to issue an actuation command because it has literally never seen an actuation command.
Yes. It only knows how to diagnose and advise. It is completely blind to the concept of taking physical control.
It's a structural limitation, not a behavioral suggestion.
Exactly.
Reading this internal draft is just a stark contrast to the standard tech industry playbook. I mean, the communications team left notes at the bottom of the document explicitly forbidding any performance claims in the press release.
Yeah, that stood out to me too.
The text literally states they haven't measured EON Delta against anything and won't claim it's better until an independently reproducible measurement proves it.
There is also an internal hold condition mandating that the release cannot go public until the provisional patent application is physically filed.
Because they know the long-term value is in the proprietary mechanism they invented, not the marketing spin.
Exactly. It is a very serious engineering culture.
As one of the executives noted in the draft, they aren't trying to build the smartest model in the world. They're just building one that has actually read the incident record, works with zero internet connection, and never sends your proprietary data home to a mothership.
Which is exactly what you need in the real world.
Right, because at 3 a.m. on a night shift, when a pressure gauge starts drifting toward the red line, an omniscient, cloud-based chatbot doesn't help you. A constrained, hyper-specialized local tool does.
It really represents a profound shift in how we might apply artificial intelligence going forward. Not as a monolithic entity that knows everything, but as a fragmented network of highly specialized tools.
Tools designed to navigate the structural, legal, and physical realities of the real world.
Absolutely.
EON Delta proves that the real value of AI might lie in solving human coordination problems.
Right.
I mean, we started this deep dive by looking at the tragedy of repeating the same industrial disasters because antitrust laws prevented us from sharing the data.
Right.
And EON figured out how to use a two-layer model to mathematically separate the lesson from the data, allowing competitors to share safety knowledge without sharing trade secrets.
And once you understand the mechanics of that architectural blueprint, the implications extend far beyond industrial manufacturing.
They really do. Think about the possibilities for a second. Could this exact same two-layer system be the blueprint needed for fiercely competitive pharmaceutical companies to jointly train an AI to cure rare diseases?
Without ever exposing their proprietary chemical compounds.
Exactly. Or what if rival global banks use this architecture to jointly identify and stop international fraud networks, pooling their collective knowledge without ever sharing a single customer's private financial data?
When you figure out how to share the teacher without sharing the textbook, the boundaries of what competitors can accomplish together completely change.
The knowledge to solve our biggest problems already exists. It's just waiting to be pooled. So the next time you hear about a massive corporate failure or a tragic structural disaster, ask yourself, is this just another car hitting the exact same pothole on a dark highway? simply because we haven't given them the tools to safely share the map.
It's definitely something to think about.
Something to ponder for sure. Well, that wraps it up for today. Until next time, keep diving deep.